In this project, we're building a simple serverless notes API on AWS. It supports full CRUD, create, read, update, and delete, and runs on Lambda API Gateway and DynamoDB. We'll start by deploying a DynamoDB table to store the notes. Each note is stored as a single item with a simple schema, the title, and the note content. You'll also see an owner field in the schema. In this project, it's always set to global to keep things simple. In the next project, we'll tie that field to authenticated users using AWS Cognito. Next, we deploy Lambda functions that power the CRUD API. Each function does one operation. The functions are written in Python and interact directly with DynamoDB using IAM roles. API Gateway then becomes the front door to the Notes API. It defines the REST endpoints and route requests to our Lambdas. This is what turns our backend functions into a usable HTTP API. Finally, we deploy a simple test web application that talks to our API. It lets us exercise all the CRUD operations from our browser and verify everything works end-to-end. At this point, we have a complete serverless CRUD application with DynamoDB, Lambda, API Gateway, and a working client. In our next project, we'll secure the same API with Amazon Cognito and make it user-aware. This means you'll need to log in first. We'll also integrate Google as an external identity provider to our API. Now we're ready to build the code. Start by going to the GitHub documentation for the video description and navigating to the Download this repository section. Copy the git clone command. Open your development environment and paste in the git clone command. This is going to download the code and put you in the correct directory. The first thing you want to do is run the checkenv command to validate the prerequisites. If this script fails, please refer to the AWS setup video. I'll put a link up here. Now we're ready to run the apply.sh. The apply is really quick for this project. The build takes under 2 minutes. As always, if you have any questions, please put them in the comment section below and I'll answer. The build has completed, so now let's go into the AWS console and take a look at what got built. We'll start by looking at the DynamoDB table to store the notes. DynamoDB is a great fit here because it's fully managed, scales automatically, and works really well with serverless APIs. We'll store each note as a single item and keep the schema simple, title and note. You'll notice the owner field in the schema. For this project, it's always set to global to keep things simple. In our next project, we'll tie that directly to the user, so each person has their own set of notes. We'll use Cognito to manage our users. After deploying the DynamoDB table, we'll deploy a set of Lambda functions that implement the CRUD operations for the API. Each Lambda handles a single responsibility: creating, listing, retrieving, updating, or deleting notes. All of the functions use Python as the Lambda runtime. The Lambda functions interact directly with the DynamoDB table with an attached role. With the Lambda functions deployed, next we'll configure Amazon API Gateway to act as a front door to the service. API Gateway defines the REST endpoints like post, get, put, and delete, and routes each request to the appropriate Lambda function. This is what turns a set of backend Lambdas into a usable HTTP API that can be called from the command line, browser, or any application. From here, API Gateway handles request routing and response formatting, with the business logic staying inside the Lambdas. Finally, we'll deploy a simple web application in a public S3 bucket to test our API. The web application lets us exercise all the CRUD endpoints from our browser and verify everything works end-to-end. At this point, we have a complete serverless CRUD application with DynamoDB, Lambda, API Gateway, and a working client. For the demo, the first thing we'll do is go back to our development environment and run the validate script. This script outputs the URL to the test application. Copy that URL and paste it into the browser. Before we start interacting with the app, let's open the browser's development tools so we can see exactly how the Notes API is being called. In Chrome, you can do this by pressing F12 and switching to the Network tab. Now let's walk through the CRUD operations. Read happens implicitly as soon as the application loads, or you can hit refresh. If you click on the request inside the Network tab, you can see the requests, headers, and then the actual response, which is the note that is being displayed. To exercise the create operation, simply select new. From new, I'll enter in new note, my new note, and when I select create, it's going to trigger a post request to the API. Post request here, that's creating the new note, my note. It's doing it as a post, so this is the create endpoint. To test the update operation, what you want to do is change the contents of a particular note. So I have my new note. I'm going to say my updated note, and then I'm going to say another line of text. Now, when I hit save, I should see the update put happen here. So I'm going to hit save. You can see I can go to this guy right here. It's a put, and its payload is updating the note from the previous one. And then the response is going to come back and say, hey, your note is created. So that is the update endpoint. Finally, to exercise the delete operation, select a note and then choose delete. Click OK on delete. This is going to remove the note by calling the delete endpoint. So if I go back to here and say, it's a delete on the endpoint, and the response that came back was message deleted. In addition to using the browser, another way to test this API is with Postman, which is useful for making direct calls to each endpoint without a UI. At this point, we've done everything we're going to do with this project, so now it's time to be a good steward of your cloud account and run destroy to clean up your resources.